Welcome to the Crazy Hat Chemist. So another video here on chemical equilibrium, video number 3. So let's get moving. Bam! So today we're talking about the equilibrium calculation number 1. Okay? So determine the value of the Keq and the direction of the equilibrium from this value. If 3.00 moles of NaCl is placed in a 1 liter flask, 1.00 liter flask, given the following equation. So I got a balanced equation. It's 2NaCl, gaseous state. I got my double-headed arrows there, or 2 arrows. That's one going in the product direction, one going in the reactant direction. That lets me know it's in equilibrium. Produces 2NO, gaseous state, plus Cl2, gaseous state. Okay? It is discovered that at equilibrium, the concentration of the NO is 0.850 molar. To accomplish this calculation, what we're going to do is we're going to use an ice table. That's what we're going to be using here. And I don't know if you remember way back, Ice Baby. That is the ice table that we're going to be using here. Okay, so what does ice mean? Ice means initial change and equilibrium. That's the shorthand for the ice. And so what we're going to do is we're going to fill out the ice table, and we're ultimately most interested in what column or what row is the equilibrium row, because we're talking about equilibrium. But the ice table will allow me to get the equilibrium row. So I start off with 3 moles in 1 liter. That's a 3 molar solution. So that's 3.00 molar solution of NaCl. Okay, now I don't start off with any of the reactants. So both of the reactants are going to be 0. Okay, so you start off with something on the reactant side, and what do you start off with on the product side? Nothing, because the reaction actually hasn't started. So since the reaction hasn't started initially on the initial column, then you always have zeros on the product side. Pretty simple. Okay? Now, the other piece of information that was given to you in the problem is that it said at equilibrium 0.850 molar of NO was there at equilibrium. So I'm going to look at my equilibrium column there, and I'm going to plug in 0.850 for the NO. Okay? All right. So now what the next step is that you're going to ask yourself, okay, how did I get to the initial at 0 for NO to equilibrium at 0.850. How did I get there? And it's actually a sum of the initial plus the change gets me a 0.850. Okay, so the initial plus the change gives me the equilibrium column. So how did I get from 0 to 0.85? Well, I had to add 0.850. Okay, now I'm going to look at this equation here of both the reactants and the products, and the NO has a 2 stoichiometric coefficient. The reactant has also a 2 stoichiometric coefficient, so it's in a same 1-to-1 mole ratio, if you will, or 2-to-2 in this case, right? Same thing as a 1-to-1. So for the reactant, which is in a 1-to-1 mole ratio as the NO, so the NO and the NaCl are in the same mole ratio. So what's the change for the NaCl? Well, it's the same as the change for the NO. So I'm going to plug that in there. Except for this time, I'm going to put a subtraction sign there. Okay, that subtraction sign is letting me know that initially when the reaction, I had 3 molar of it, and it's going to have to decrease in concentration. Since it's a reactant, it will decrease, and the products will be produced. That's why it's a plus sign on the product side, plus sign on the product side, and a minus sign on the reactant side. Okay? And now I'm going to add up the 3 molar and the minus 0.850 molar. Okay? And then I'm also going to figure out what goes in the Cl2 column for the change. Now notice the stoichiometric coefficient is different with the Cl2 and the NO. So I'm going to go for those two right there. I'm going to compare them. And the NO has a 2 in front of it. The Cl2 has a 1 in front of it. So therefore the Cl2 is going to be 1/2 that of the NO. So okay, so I'm going to add the 3 and the negative 0.850. That gives me 2.15. And then I'm going to add 0.425, which is 1/2 of the 0.850. So that 1/2 of the 0.850 is going to go right in that place right there, because the mole ratio is 1/2 that of the NO for the Cl. Now I'm going to add up the columns here of the 0 plus the 0.425, and I'm going to get the 0.425. So what I'm interested in is acquiring the equilibrium lane here, the equilibrium column, okay, and the equilibrium row rather, right? So the equilibrium row is the NOCl is a 2.15, the NO is a 0.850, and the Cl2 is the 0.425. How did I get that? I had to do an ice table, and I started off with my 3 molar of my reactant, 0 for both of the products, and then I was given a concentration at equilibrium, and I worked backwards from that value. The reactant is a subtraction on the change. The products are a positive, an addition of the change, because the reactants decrease, therefore the minus sign, and the products increase, therefore a positive sign. And you're going to add up the initial and the change to acquire the equilibrium row. Okay, so once you acquire that equilibrium row, now we're going to fill in the rest of this so we can acquire the Keq value itself. So that's what we're interested in. That's why I'm highlighting that, the equilibrium row. We're going to write the Keq expression. Now remember, from the previous slide, the previous lecture, okay, we had a Keq expression. And how do you write that? It's products over reactants with the stoichiometric coefficients as exponents. Products over reactants with the stoichiometric coefficients as exponents. Solids and liquids are not included. Are there any solids or liquids in this problem? No. Everything's a gas, so I don't have to worry about that. So I'm going to write the Keq expression. That's right here. That's Keq is equal to NO to the second power, Cl2 to the first power, divided by NOCl to the second power. Okay? All right, so now what we're going to do is we're going to plug in those equilibrium values in that row right there, okay, into the Keq expression. So I've just plugged in those numeric values at the equilibrium into that Keq expression. And so the NO is replaced by a 0.50, the NO is replaced by a 0.850. The Cl2 is replaced by a 0.452, and the NOCl is replaced by a 2.15. Now what you're going to do is use your calculator, get the numeric, the mathematical value of the Keq, and that's what I have right here. Okay, it's 0.0664. That is the value of the Keq. Okay, this value of the Keq is less than 1. That means that under these conditions here, this reaction is reactant favored. Okay, reactant favored. That is that the arrows lie to the left towards the reactants. The Keq value itself is a unitless number, so there's no units on the Keq. That's why there's no units there. I normally have number units formula, but there's no units here for this, no formula for it as well. It's just a numeric value. Okay, and I want you to look at that equilibrium constant expression, and I'm going to put a different arrow there. So knowing the value of the Keq, knowing that it's less than 1, that means that really I don't need to have the two arrows being equal in length. Since it is reactant favored, I'm going to have the longer arrow towards the reactants and the shorter arrow towards products. So my teeter-totter here is really kind of teetered on one side, and that one side that it's teetered towards is the reactant side, since this is reactant favored, and the Keq is less than 1. The Keq values are always positive values. They're never negative, but they can have negative exponents, as this number 6.64 times 10 to the negative 2 would, or the 0.0664, same thing. Okay? All right, that is just the basics of that reaction of the first equilibrium reaction. And I've got a taco on my head. It must be Taco Tuesday, and I'm getting kind of hungry right now. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. Find my website, and you can get some merchandise pretty soon. All right, see you later. Bye for now.